Okay, so we're starting to get into our triangle congruence formulas, or postulates, I should say, not formulas. So these are kind of some ways to prove that two triangles are congruent. So the first one we're going to talk about is the side, 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 and you'll see it written as 3 S's postulate. So that means that if all three sides, so if each side has a corresponding congruent side to another triangle, they have 3 common sides in a row, then the two triangles are congruent. So that means their angles are congruent, their sides are obviously congruent. So this is one way to prove that two triangles are congruent. Okay, so let's just get right to it. So how we're going to do this is we're going to prove that the triangles are congruent by proving that all 3 sides are congruent. So don't worry, this is not a hard proof, you can do it. So you have your statements and you have your reasons. Okay, so they give you LM is congruent to NP and LP is congruent to NM. The reason is given. Okay, so they said LM, which is the bottom, is congruent to the top. LP is congruent to NP. So what do we need to do in order to prove this by side, side, side? Well, we need to figure out the last side. So the last side on both of these triangles is right here. So is LN congruent to LN? Absolutely. All right, do you remember the property that says it's congruent? That would be the reflexive property of congruence. Okay, so now that we have listed all 3 sides, we're pretty much done. We have enough. So we have enough to say that the triangle, and I'm going to write it exactly how they have it because they already have it in the right order with the corresponding angles. You don't even really have to think about it. So triangle LMN is congruent to triangle NPL. And why? Because of the side, side, side postulate. Literally, that's how easy it is. Just make sure you have all 3 sides listed, and then you can do the side, side, side postulate. Okay, this one's very similar. Pause the video, try it by yourself. So we've got our statements and reasons. So statement 1 is BC is congruent to BF, and CD is congruent to FD. Oops. And the reason is given. Okay, so they just told us that we have 2 sets of sides that are congruent. So what do we need in order to prove that these 2 triangles are congruent to each other? Just that last side. So BD is congruent to BD. This is that side that goes through the middle, that goes through both triangles. And what's the reason? Well, again, it's just like the last one, the reflexive property of congruence. Okay, we've listed all 3 sides. Do we have enough to say that those 2 triangles are congruent? Yes, we do. So triangle BCD is congruent to triangle BFD. And that would be, what's the reasoning? Well, side, side, side. So the side, side, side postulate. Easy. Okay, so now, so something that angle relationships. So you show control relationships between a pair of corresponding sides and an included angle. The word included refers to the angle and the sides of the triangle as shown. So angle A is included between BA and AC. So that's included. BC is included, let me switch colors here. So BC is included between angles B and C. Okay, something handy for you to know, but we probably won't use it that much, honestly. Okay, here's the next one. You will use this, so you need to have this memorized. So the next triangle postulate, we just talked about side, side, side. The next one is side, angle, side. So whenever you're doing this, you have to make sure that it has side, an angle in the middle, and another side, okay? If it's not the case, if maybe the angle is not in between the two sides, it does not work. Okay, so angle, side, angle, or sorry, side, angle, side is away. Oh my gosh, what did I just do? Okay, so what other information do we need to prove that DEF, triangle DEF, is congruent to FGD? Well, it looks like we have a side, on the top and the bottom, and then the middle, obviously. So we'll need to know that this angle is congruent to that angle. So we either need to know that angle EFD is congruent to angle FDG. So they wanted us to prove by side, angle, side. So that's what we would need to know. Obviously, if we had the third side, we could prove it by side, 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 but that's not what they asked us. So this will be your answer. Okay, would you use side, side, side or side, angle, side to prove the triangles are congruent? If there is not enough information to provide the triangles congruent by side, side, side or side, angle, side, write not enough info. So this one we've got two sets of sides and one angle. Is the angle in between the sides? Yes, it is. So this would be side, angle, side. Okay. Next one, so we have two sets of sides and one angle. Is the angle between the two sides? Well, it is on this one, but it's not on the right one, so that won't work. So there is not enough info. Okay, next one, looks like we have all three sides on both of them, so that would be yes. Side, side, side. Okay, this next one looks like we have all three sides. Be side, 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 but it could also be side, angle, side. And if you notice, these are vertical angles right here, so they must be congruent. So you could say side, angle, side. Okay, so it could be either one, side, 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 or side, angle, side. And this was a short lesson. That is it for 4.2, side, 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 and side, angle, side. There's a few more, but that's all we're getting to in this lesson.